Okay, welcome everyone. This is Kate Sonka speaking, the executive director here at Teach Access. Welcome to those of you who are new for this session. Hello to those of you who have been with us along the way. I am very excited for this session. Nothing is more exciting to me than hearing from students. So I don't want to take too much time away from them, but it's important that we share a little info with you here. So in terms of the academy here, go to the next slide. If it's working. Okay, there we go. Just the accessibility options available to you here. There is a button along the bottom of your screen with CC inside of that. If you'd like to access the captions, you can click that button. We also have ASL or American Sign Language interpretation available. That will always appear for you on your screen. If there's anything else you need, please send us a message via the chat. It will go to the host and the panelists, and we'll be able to help you with any questions that you have. So feel free to contact us at any point. Okay, and finally, the last one here, important for us to thank our sponsors of the event who helped make this possible for us to offer at no cost to you. So a thank you to Microsoft, ADP, Google, Meta, Salesforce, and Skyscanner. So a big thank you to all of those organizations. Okay, and now I'm so happy to introduce this wonderful team of students. They'll share more about their project, but this is the Cornell Assistive Technologies Project Team, or CAT, CAT for short, which I appreciate as a CAT person. And this is a student-run organization focused on inclusive design and disability advocacy. And they have some slides that they'll share about some work, but I'm thrilled to introduce to you today Savas, Lila, Rashab, and Shannon. And I will turn it over to you all. Thank you so much.
Hello, everybody. I am Savas, person speaking, and today I'm here to share with you our project. It goes beyond sites, borders, and budgets, and it's called the Tactile Coding Blocks. I'm here today with a couple of my colleagues. I am a sophomore studying electrical and computer engineering at Cornell, and I'd like to introduce Lila.
Hi everyone, I'm Lila Aldereti and I am a junior studying computer science at Cornell. I've been working on the software side of the Tactile Coding Blocks project using the auto generation software.
And then my name is Shannon Lin, and I'm a sophomore studying computer science with an emphasis in web accessibility. And I've been working on the software and the mechanical engineering side of this project.
Hello, and my name is Rashab. I'm a sophomore studying mechanical engineering at Cornell, and I've been working on the mechanical design side of this project.
All right. So next slide. So the problem that we want to address with the tactile coding blocks is that existing tools to learn computer science are prohibitively expensive. They can cost up to and over $500 per set, and advanced computing concepts are not taught very well by these existing resources. Furthermore, the knowledge is not necessarily transferable between softwares with existing tools on the market. Over here, we have an image of an existing tool called CodeJumper, and this has some of the issues that we've described. So the solution that we've developed is the tactile coding blocks. It costs less than $15 to manufacture, and it can be made hypothetically in any coding language and used anywhere through the power of 3D printing. Customization is also built into the tool, from the texture of the tactile coding blocks, the color scheme for various visual needs, and even the specific language that we use for the blocks. And over here, we have an image of the tactile coding blocks with someone actually reading the Braille by touching the blocks themselves. So, a bit of context, we've been working on this project for the past 3 years now. From June 2023, there's an image here of the initial set all the way to the left of the screen of the tactile coding blocks. This was built on Scratch for St. Joseph's School for the Blind. In July 2024, I brought this to the EPIC conference at Washington State School for the Blind, where I taught a room of 70 teachers how to actually use the product, and they each went home with a set of their own tactile coding block kit. In February 2025, I brought this project to Cornell Assistive Technologies, and over here to the right of the screen, there is an image of a bunch of the students on the team, and this is where I brought it, and really the project has flourished since. Then in September 2025, I'm here with 2 members of the team. That's the image on the screen. At the Island Conference hosted at Princeton University, where we were able to get some feedback and get some exposure on the project. Then in December 2025, we sent the project internationally to the UK to get user testing from Microbit, where we actually made specific tactile coding block kits for their coding language. And over here, you can see an image of someone actually using the Microbit kit and touching the Braille and reading. Then in January 2026, we were contacted by MIT Media Lab, in particular Octo Studios, where we are developing a kit of tactile coding blocks for them specifically. And over here, it's an image of an octopus with various colored tentacles for the logo for Octo Studios.
Hello, so this is Rashab speaking now. On the screen, we can see this is some of the coding block design considerations that we've implemented in the mechanical design side using user feedback. And so some of the considerations we've had to make were material. Specifically for 3D printing, it's called filament. We were deciding between TPU, which is a more rubbery texture, versus PLA filament, which is a little more rigid and like normal plastic. We decided on using PLA because it has a better feel for the braille and makes it more clear. We also worked on rounding some of the edges out, and this is because the audience for this product is children learning coding, and so the rounded edges would give it a better feel. We also worked on redesigning braille. A lot of 3D printed braille can be uncomfortable to the touch, and so we adapted that design, making it more comfortable and easier to read. As we can see in the right picture, some of the blocks have this extension called a dovetail connection, and those allow us to create longer chains of text and code, allowing for more complex code to be created with the blocks. An issue that a lot of screen readers have specifically with understanding code is understanding where indentations are. And so what our blocks are able to do is showcase this indentation within the code structure, which is a really important concept in learning that. In addition, on the blocks, they have a raised edge, which allows for understanding of orientation. And finally, all the blocks are modular with each other and are compatible, allowing for a small set of blocks to create many different types of lesson plans. And so here we can see an example coding lesson plan. On the top left is an image of a block that says if in range, and this is an example of Python being adapted as a coding language, and that's one of the test blocks we created, being the for loop block. Below it in the bottom left, we have the for loop counter. This was a 3D printed counter that, as you turn, has clicking feedback and braille on it to allow you to keep track of the for loop iterations. In the middle, we can see a call frame block. Call frames are a coding concept related to functions that are taught at the college level, which shows the impact that these tactile coding blocks can have. And on the right, we can see the corresponding code to the 3D printed call frame block, defined to centigrade, which details the function, and the call to centigrade function below. Here, this is our code the blocks that we adapted for microbit. On the right, you can see microbit's make code, and a screenshot of that where it says on a button pressed with some play blocks in addition, and that's the corresponding code. On the left, you can see our sample 3D printed blocks, which we created exactly from the corresponding code.
Hi guys, it's Lila, and I will be talking about our Tactile Coding Blocks auto generation software. This software takes Quorum code as input and outputs 3D printing files needed to teach the inputted Quorum code to a class of students. Then the teacher can download the 3D printing files with the press of a button. Currently, we have the action block, say block, class block, and end block fully functional. This process is meant to be really inexpensive and easy for the teacher to utilize and understand without a lot of technical or CADing or computer-aided design experience in the past. It's also extremely customizable for any teacher's lesson plans. Here is a quick video that will walk you through the auto generation software by generating the action block. So first you type in the command action main, you hit the generate button. The code will now make the 3D printing files. You hit the download OpenSCAD button. OpenSCAD is a software that automatically generates 3D printing files that would otherwise have to be made manually. Then we can download the STL file. The STL file is the actual 3D printing file, and there it is on the screen with all of the indentation and braille of the action block.
And hi guys, it's Shannon again, and now I'm going to walk you through our website using this video. So this is our homepage, and then at the top you'll see a photo of our team, and then below that we highlight some key facts about our tactile coding blocks in the form of Python code, which is pretty relevant. And then the next is our products page, where you can explore and use the tools that we've developed. Here you'll find our tactile coding block kits along with downloadable 3D print files. So these are STL files packaged in a zip folder. And then within the product section, we also have a dedicated page for our collaboration with Microbit. On this page, you can download pre-made Microbit project sets, order Microbit-specific tactile block sets, along with access the online Microbit block editor, also known as MakeCode. And these are just some of our pre-made sets. We have Doorbell along with our Shake, and I'm just showing you the MakeCode demo here too. And then you can also find information about our current design, as well as details about the design process that we discussed earlier. And then this is the design process that Savas talked about in the timeline. And then this is our Why Us page, where we introduce our team and share some testimonials. One testimonial that really stood out to me was that within an hour, students were able to build, test, and modify programs using the tactile system. And then finally, this is our Coming Soon page, where we share some exciting features and developments that are coming up in the future.
Hey, this is Savas speaking again. I'd like to close off by giving a special thanks to some of the people who've made this project possible. So Ian Maddie and Richard He from the Mountain Lakes Public Library Makerspace. This is sort of where the project originated, and they have worked tirelessly to sort of get this out there and share this with more people. That is part of why we are here today. Andreas Stefik from Quorum Programming Language. This is what made it possible to collaboration with him made it possible to share the tactile coding blocks with over 70 teachers across the country at the start of this project. I also want to thank Mace Lewinsky and Lucas Keith. They are wonderful team leads at Cornell Assistive Technologies, and they've made sure that we've got the funding and the right equipment to develop these tactile coding blocks. I also want to thank Emma Posey from Microbit for collaborating with us and getting us some international user testing, and Aaron Dodson from Google Blockly, who has helped us tremendously with sort of developing the auto generation software and our website. And over here, we have a couple of images of our contributors. So to the left, we have leadership. So the two team leads, myself and William. And then we have the software engineering team. So we have Shannon, Lila, Madhu, and Sahana over here in the middle. And then on the image all the way to the right, we have Shannon, Rashab, Andy, William, Emily, and Sahana there. Yeah, that concludes our presentation. Thank you.
Amazing. This is Kate speaking. While we wait and see if any questions come in. Oh, someone did ask, what is the URL for your website? If that's something you can share, we can drop that in the chat. But I'm curious. So the work that we do at Teach Access is to get students, all students, interested and involved in accessibility. So I'm curious for you all, since you've been working on this project and thinking through this, how do you talk about it with your peers or with some of your other friends who maybe aren't thinking about accessibility at this point? How do you sort of encourage them to get into thinking about this and including this in the work that they're doing?
Yeah, sure. I mean, one thing that has been really essential is joining Cornell Assistive Technologies. We're a student team that really cares about accessibility, and I think a huge part of it is sort of looking to your outer community, looking at the clubs and organizations that you can get involved with like-minded people who care about this. And then the outreach step, we do have a whole sub-team dedicated to outreach and education, so reaching other students, families, teachers, and sort of getting word out there about the work that we're doing and connecting different people, if that makes sense. I'm not sure if anyone else wants to chime in here, but that's my input.
Yeah, my name is Shannon again, and then I would like to touch on like my experience as a computer science major. So basically, like in classes, like accessibility in computer science really isn't talked about, whether that's like web accessibility or anything else. And I find it like really helpful to just like spread it through word of mouth and like show people like tools they can use, such as like the Wave extension that they can like just check for website accessibility with.
This is Kate. I love those answers. Because we encourage, students to enter into this in any way, whether it's with technical backgrounds or programming and coding like some of you, or maybe it's through writing or through technical writing or management, HR, and any future job you have, really knowing something about disability or something about accessibility is so important. So we're really excited to hear from all of you today. There is one other question in here. Someone has asked, what is the timeline for the public availability of the product? Does anyone have an answer for that?
Yeah,
Yeah, so
sure. Right now, what we're working on is actually completing the ordering page such that someone could actually order a set of the tactile coding blocks. We're hoping to have this complete by the end of April. And right now, we also have to purchase the domain, but basically, most of what we have is already built, so it's coming really, really soon.
that's exciting. This is Kate. One question I see here. Would this be something that adults new to coding could use? And if an instructor already has lessons, can this be used to adapt existing labs? That came in through a message and not the QA box.
Yeah, this is Savas speaking. I apologize if I didn't introduce myself last time. I would say this is definitely a tool that an adult can use. There's no age limit. I would say that the lessons are a little bit elementary, but we are working on making those advanced concepts. So that could potentially be useful to an adult. And I would say that an instructor could definitely use it to adapt their existing labs. And we have worked on the auto generation software. And if this is something that people are interested in, we could develop it further so teachers can develop like completely customized lessons as their needs.
This is Kate. Amazing. So I think the key is for everyone out there to follow along. If we haven't already shared your URL, if one of you wants to share that with one of us, we'll make sure we send that out to everybody. I can't believe it. This time went so quickly. We are up against time here, but I want to thank you all for making the time to join us today, hearing about the work that you're all doing. You are the future of this field of accessibility and working in tech. So we're so appreciative that you're already thinking about these things and interpreting and incorporating this into your work. So I want to thank you all. Enjoy class if you have to go to class later today or tomorrow. Nope, tomorrow's Saturday. Next week, whenever you're going to class. But thank you all. We're excited to see where this goes and appreciate you joining us today.
This is Shannon. Thank you for having us. Y'all have a good day too.
This is Lila. Thank you so much. It was awesome being here today.
This is Sabas. Thank you all so much.
And this is Rashab. Thank you also.
And this is Kate. We'll see you all in about 15 minutes. Our next session is called Using Personas to Design for Differences. So we hope you'll join us in that one. Thank you so much, everybody.